Okay, everyone. Thank you so much for having me here today. It's sad that this is a virtual event, but still, I'm pretty excited about everything that is happening here, and I'm having an opportunity to actually speak to you here. So I'm going to talk a little bit about what we do at the Bosch Center for Artificial Intelligence at Bosch, and one of Bosch's core values is always invented for life. So we always also try to care for really make it useful for humanity and not just for clicking ads or something like that. So today, I will start a little bit with a general overview for those of you who are not so sophisticated in the field of AI, showing you what is actually AI. After that, I will also show you a few of the Bosch use cases we actually have in the Bosch Center for Artificial Intelligence. We are trying to enable the whole Bosch organization to make use of artificial intelligence, and therefore it's pretty clear that we have a big amount of different topics, and I can only touch on a few of them. And in the end, I also will show a few of the challenges we actually have. So when on the street, when you walk through the street and you would ask anyone, what is AI? Probably they would come up with something like that. So most people, when they think of AI, it's the small, tiny, small, funny robot R2-D2 beeping around, but being helpful, or data, the perfect humanoid android, being able to interact and even having feelings. Or in the worst case, they will think of something like Terminator, machines killing or going to kill us. If you ask the same question someone in the field, the answer normally looks a little bit different from that. We are far from anything that is here, but this is what most people coming from the field itself will think about if you ask them what is AI. I took the definition in the top from a textbook. So there, it's a very dry definition of the study of agents that receive percepts from the environment and perform actions. So what does it actually mean? When we talk about AI, it is actually really about so-called intelligent systems, and those intelligent systems actually are divided up into three different parts, or you can mainly divide them up into three different capabilities they have. There's on the one hand the perception part. Perception is for a machine or for this intelligent system, the way how it can actually perceive the surrounding environment. Most people will think about computer vision, but it can also be signal processing. For example, in manufacturing, in the industry, sensor data, recording sensor data and working on it, this is signal processing. This is some kind of perception of what is going on in the environment. The next part that is interesting is the understanding. When an intelligent system perceives the environment, it is actually interesting, how can it make something out of it? First of all, when people think about understanding in AI, they will say something like natural language understanding, meaning a machine can read a text and understand what is written in it, can summarize it, or can extract important information out of it. This is one part, but the other part is also general knowledge representation. How can we actually represent all the different knowledge that exists in the different data and in the perception, and then actually represent it so that we can act on it? And this immediately brings us to the last part, which is actually the acting. How can an intelligent system, now with having observed the environment, understanding what is going on, actually do some acting? Typical applications here or technical examples are robotics, a robot arm gripping something, laying somewhere, or turning something, or on the other hand, more general reinforcement learning, what many people might have seen already in computer playing games better than humans. So this is in general what we talk most about when we talk about AI. So now we see in this event there is a lot of interest in AI in recent years. And this is actually quite interesting, because is it really a breakthrough? No, it's actually not, because artificial intelligence, if you look back in history, already in 1956, John McCarthy actually invited to the artificial intelligence summer camp a lot of his colleagues. And there the task was really to think about how can artificial intelligence be created? What is it? What can we do with it? So it's in no way anything new, but it is actually a really, really old field by nowadays by computer science standards, since it's already more than 60 years out. So this brings us immediately to the question, why is artificial intelligence now so important, or why is it now so interesting for the world? Why is everyone speaking about AI, and how can it help us in society, and how can it help us in the industry to become better, to create better products, or to do better manufacturing? And actually this answer is threefold. First of all, if you look at this is something that was not available in 1956. Big data centers where tons of data are stored. 90% of today's data were actually created in the last 2 years. If you look at YouTube, for example, 300 hours of video are uploaded every minute. Or in Google, every second 40,000 search queries are made. Or if you look at Facebook scale, it's like 150,000 messages, more than 150,000 messages sent per minute. So it's this tremendous number of interactions, of data points being created every second. And what is also different is nowadays it can be stored. We have ways to store this data and to retrieve it. We don't need tapes or even written books where it's stored. It is completely accessible by computers to download the data that you need at the fingertip. This is part one. The other part is actually that computational power is also massively rising. The same computational power is every 5 years 10 times cheaper. Just to put this into perspective, that's like since 1940, 10 to the power of 15 times cheaper. That means what back then cost a fortune and not a single person on the planet could buy is now in every one of our pockets. It's in every single smartphone, and even in the cheapest smartphones is computational power that was unthought of back in 1950, 1940. So this is also then enabling to work actually on this tremendous amount of data that is being generated constantly. And then we also have progress in algorithms. This is now the researchy part. This is the stuff where we learn how to work actually with this huge amount of data, and where we had the big advantages besides computational power and data in the past years. Just as an example, at Bosch, in 2018 alone, we had 23 publications at top tier conferences, and this was just 2018. In 2019, it was more, and in 2020, we also already have much more than just that. So it's a constantly growing field, and the research is really accelerating a lot. So what is new nowadays? There is still some new. It's not that it's just the data, it's just the computation, but what are those new algorithms like? When you look at traditional programming is can be thought of as this tree structure. You have a starting point in your program somewhere here, and then you have decisions you make, walk down different paths in the program to come to a decision. For example, if you want to decide if something is good or bad, you need to look at all those features there. This was then so-called rule-based knowledge or explicit knowledge. It required experts to really write these decisions. If this part has pattern A, then take this path. If it has pattern B, take this path. And then do all these decisions on all these different nodes. And it needed experts to encode this and to really manifest it in code. So these experts were not only programmers, but also domain experts of the things. They needed to know what is going on, for example, in the industry or in manufacturing, to make the correct decisions. Now, if we look at how it's looking today, the machine learning models, so-called models that are used to do some kind of classification, it looks completely different. This is the typical picture for something that is used today. It's a neural network picture, how you would depict it. And the difference here is now we put a lot of implicit knowledge in there. It's data-based. So the model is adjusting itself, the connections here, to make then in the end a decision. This is independent if it's just a neural network or if it's some other machine learning algorithm. This is the new paradigm. So we actually have a paradigm shift from programming to training computers. We give them a lot of data, and the computer then learns from itself how to do things. And now comes the fun part. Working for a big company like Bosch with a lot of industry experience, or working together with companies in the industry who are experts and who have all this explicit knowledge, there is also a way to bring this explicit knowledge into the new world and make use of it and not throw it away. We don't need to learn everything from scratch, but we can really make use of the huge amount of data that we might have in our use cases, but also of the experts who know how this data actually works and why it works like that. So this brings us to the main topic or main point, why AI is now such an interesting situation, that it is transforming whole industries, that it is opening up new possibilities that were not thought of before. It's really a lot of benefits come from the learning from data, because with learning from data, we can actually learn new functionalities without knowing ourselves exactly how they work. The computer is able to figure out from the data how it can actually make use of the features that are available in the data and draw new conclusions from it. We have a much shorter time to market, while in the past we needed experts who were domain experts to really develop algorithms that make decisions if some part is okay or not okay, or what the forecast will be. Now the computer will learn from the data. Our main constraint is computing power and data availability nowadays. And if we have enough computing power, we can be much faster. So the time to market can be reduced tremendously. And related to that comes, of course, also more efficiency in what we do. So to put this all a little bit into numbers, what really happened and what this really means, let's look at this. This is actually what is happening, or what has happened over the past 10 years in the field of image classification. A lot of people, when they think of AI nowadays and have read a textbook or watched some online courses, image classification is one of the tasks that is mostly used for explaining this is machine learning and this is AI. And back in 2010 and 2011, on a big image classification task, on the biggest evaluation task back then, the question was, how good are computers to classify these images? There were images of 1,000 different things and lots of images with these 1,000 different things. And the computer was asked to classify what is on the image. And back in 2010 and 11, we had error rates of more than 25%. So every fourth image that was classified by a computer was essentially wrongly classified. This is pretty bad. You can't use this in any real industrial use case if you have normal constraints in what error rate you need. So this is actually way too high. And then in 2012, something interesting happened. Suddenly, there was a huge drop. And this is actually just one system that was happening in 2012. The other systems were all still in this error rate classification. So this was a yearly competition. And this one system was around 9% better than every other. 9% absolute improvement. And this is big. This is insanely big, never seen before like that. And what happened there was, this was the time where someone for the first time successfully applied a so-called deep learning network to image recognition. And this gave such a big improvement that every other system was just far behind. What happened next was, in 2013 already and 2014, there was no classical machine learning used anymore. Everything was based on deep learning in the classification. And we see that the error rates dropped tremendously. Now, the question is this good? Does an error rate of 2.5%, or I think it's now 1.8%, I don't know the exact last numbers, is that actually a good number? Yes, if you put into context what actually humans are capable of, then you see that the computer is outperforming since 2015 human performance. The computer is better in classifying these 1,000 different classes than humans. And it is clear that this is possible. If you just look at the images, it's, for example, about different dog breeds, understanding which kind of dog breed you are looking at. So this is just to give you an impression of how difficult this task really is. And nowadays, the computers, the machines make less than 2% errors on this task, which is really, really good. So we have the situation that human performance is nowadays surpassed in selected narrow areas. I would still like to keep this narrow areas, but we surpassed actually human performance. This happened already some time ago in Jeopardy. You might have known that a computer by IBM Watson, was actually beating the two best human players for Jeopardy in creating the correct questions for the answers. And recently, AlphaGo by DeepMind, Google DeepMind, was beating the master of Go. And this was also kind of a surprise because no one expected it to happen so soon. Actually, Go is such a complex game that no one expected that a machine could do it so soon. And this is actually interesting because this is really coming from new aspects of doing it. There was, for example, the approach they used there was really reinforcement learning, where a computer learned to play against other computer players, or again, learning from other past games humans played, and then actually also playing against itself and constantly improving and learning from how to play just by playing against itself. And just the fact that we have so much computer speed allowed this game, or this AlphaGo, to play millions of games against each other, and therefore then learn and outperform humans on this. Now, you already see on the left side IBM, on the right side Google. So how can we actually beat the AI giants like Google, IBM, Facebook, Microsoft? Because they have a lot of data. So we can beat them on the technology side. But on training data, that is going to be really, really difficult. Just as a comparison, there was one article where, or one paper where Facebook explained that they were able to train a super high quality classifier for ImageNet, and they were able to actually leverage all their unsupervised data from Instagram and from user posts to really train this, simply because they have really, really a lot of data at their hands. So what we can actually do is really leveraging the synergies that make us experts in industrial and AI. So we can really leverage the knowledge we have from having manufacturing, for example, Bosch, more than 270 plants worldwide, with all the production data available. And we have the experts who know about how to do the manufacturing. We have the engineering experts, and this is really where we are able to build high-class and highly efficient AI products that can compete worldwide. So let's also look a little bit more into details what we are talking about when we are talking about the specifics of AI. There is, first of all, supervised learning is what most of the problems you will face in reality are actually about. Supervised learning is about creating a model that is able to generate from some input signal that you have some output. And we are leveraging there a lot of labeled examples. That's the supervised part. We have a lot of examples which we know exactly how they should be classified. And as examples, you can see in the quality inspection, optical inspection in the industry or in plants, you can get a photo and then decide if it's okay or not okay. Injector sensor data, which is really the sensor data and which then needs to decide if the injector needle is open or closed. We also have data for that and can do this. Customer specifications, so customers send us text specification and therefore then creating structures of test files, tomato greenhouse conditions, to predict the risk of a disease in a greenhouse just by the sensor data of the gases in the greenhouse, and also predicting sales and economic data by leveraging the fact that you have past information of the sales and economic data. The next part is unsupervised learning, which is about extracting knowledge automatically. Here is the task completely different. We just have some data and we now need to identify it. And here you can see actually a point cloud for audio data that was recorded, and automatic clustering then actually allows to identify different parts, like this is how a car sounds when the streets are wet, this is how the car sounds when there is a tunnel, so that you can automatically cluster and identify things, and also can identify anomalies. And then last but not least, reinforcement learning is really now learning how to act based on the observations we have to maximize actually the reward. For example, in drilling, automatic drilling, how fast can you push forward without breaking the bore and still keeping a good hole in the steel, or resistance welding to minimize the wear on the electrodes. These are, for example, typical applications for reinforcement learning. In general, when you think about AI in manufacturing, everything is coming from the data. Like I said, we have lots of data, process data, test data, machine data, image data, and so on. And then coming from there at Bosch, our approach is to really look at the different use cases we can generate from them, like cycle time and test time analysis to reduce tests, predict tests, root cause analysis to understand why something failed, optical inspection, field failure analysis. And then based on these use cases that are there, we find the highest return of invest and highest impact projects to then make the biggest impact actually with AI. To go also into a little bit of detail here, one typical example for AI is this automatic optical inspection, where it's really the task to decide on camera images if a produced part at the end of a production line is really okay, or if there is a failure on it, which can cause malfunction in the field in the end. And this is a really difficult task. You can see here in the upper part and in the lower part, there is not such a big difference. Still, one is not okay and the other one is okay. So this is really difficult, and we need a very high accuracy to classify this. We want to have very low error rate, and to get this, we have some training data. But on the other hand, there is also very few not okay examples, defect examples available, because it's less than parts per million that we create failures, and that means if there are even different failure classes, there are only very few examples overall. So it's really a challenge to create high accuracy classification methods for these kind of things. Another part where we also use, for example, AI in production, which is also quite interesting, is, for example, the production scheduling. Here the question is, how can we actually schedule different steps in the manufacturing fab for wafers, which has many different steps and many different lots going through this plant at the same time? How can we actually make the most use and then really make the get the highest throughput? And if you just compute the different numbers of computations, it's more than atoms in the universe possibilities that this could be done and that the things could be scheduled through there. And there we have some interesting AI approaches, that can help improving this and generating fast throughput there. So here we really were able to generate, for example, 5% throughput increase in one single work center alone. and were able to increase the standby with work in progress, to decrease the standby with work in progress there, and were really able to optimize schedules. One feedback from the plant was then that nobody would intuitively do it like that, the scheduling, but it is actually better. So they were actually kind of surprised that it was done like that by the computer, but they were happy that this was actually shown that it is new. Coming to some challenges that you will always face when it comes to AI in the industry and in the application. The problem with AI is really the lab environment is totally different to what the real world is. In the open world, things are not as well behaved and controlled as before. So suddenly you have to really handle the whole incompleteness and uncertainty in everything that is happening. Suddenly lightning conditions can change, or rules can change in the streets if you have a self-driving car, or you can, for example, suddenly use different materials which have different reflections. A lot of stuff can change and can then actually influence how your system is working. And therefore, you really need to plan for effort to bring your lab environment situation into the open world. And it's not as easy as if someone sees a paper that is published at Europe's, one of the best conferences in AI, that you can just take it out and immediately implement it. It needs some responsibility to do it, and some real deep understanding of what can actually happen in the real world. This brings me also to kind of the closing mark here. AI should also be seen as double-edged. It's for us at Bosch, like I said, we stand for invented for life. And therefore, it is important for us that the AI, in the end, really enhances quality of life, that there's a value proposition for products and services, that they are decision support systems and have positive impact on employment. And it's not like that we just take anything because it will reduce cost or anything else. The ethical values are important for us. And coming with this is really the importance also to look at things like unintended bias. We all might have seen the examples where some tech company was using an AI to decide for applicants if they should be invited for an interview or not. And then suddenly they figured out that a woman and a man with exactly the same qualifications, the woman was not invited because the AI rated her lower. And this was simply, it was trained with their current employee base, which is male heavy. So these kind of biases are always there in AI, and this is something that needs to be looked at. And it's the same as for malicious design or harmful strategies that can be used. This is something that needs to be put an eye on, and that is really important for us at Bosch as well. So with that, I'm closing. I'm really thankful for the opportunity again. And if you have some kind of questions, please feel free to ask.
Absolutely, Kai. Thank you very much for your keynote. And I would like to ask you a question first. There is a huge level of robotization and artificial intelligence in the automotive industry, which is a big part of the industry in both countries, in Germany as well as in Czech Republic here. What are the other industries where do you see the fast start of the artificial intelligence at this moment or in the close future?
So I think in general, in manufacturing, I think there will be a big shift. I think manufacturing, not only automotive, but in general, the global manufacturing is currently not as digitalized as it could be. And I think there is a lot of potential that their AI will actually help once the data is available and once things are digital, that you can then start optimizing schedules, optimizing line shifts, and also finding better parts for test time reduction and things. I think this is definitely, there is a lot of potential in this field.
Thank you. One question from the audience is related to intuition. What about intuition as part of artificial intelligence? You know, this is this interesting topic which Gerd Leonhardt is talking about: algorithms versus androrithm. So, what's your perception on it? Okay.
Yeah, that's a very good question. I think there is not really a good answer I can give right now. However, what you can see is, I think for me, this AlphaGo or AlphaStar was really one of the interesting situations in AI for that. This is something which surprised the world, that suddenly a computer was able to beat a human in the game of Go, where in the past, always the argument was this can't happen because a human has an intuition what is a good position. And for a computer, it was the classical approach in chess was just looking 5 moves ahead, 6 moves ahead, 10 moves ahead, and then becoming better by that. With Go, this was impossible because it's just too big of a search space. And there, this approach of playing against itself trained the model to get some understanding of the whole position, what it will lead up in the end, which is probably the closest to intuition, I would say right now. In general, I think this is clearly an open topic, how to deal with this in the future.
Mm-hmm. Thank you for your answer. Maybe last question, because we are running out of time a little bit. You explained some of the specifics like product scheduling. How did you handle the explainability in the production scheduling? It's a question of the audience.
Okay, so it totally depends on the different kinds of algorithms you're using. There are some kind of algorithms which are not as bad as neural networks. So we have some research in neural networks as well, how to make them more explainable. But actually for the production scheduling, we are using more classical machine learning, where it is where it is much easier to understand why they do some kind of decisions. Another part in this answer is also, you should also look at the requirements for the explainability when it is required for what reasons. If it's for production scheduling, yes, you need some kind of explainability, but in some cases, it's simply you don't. On the other hand, as soon as it affects humans, you want to have it explainable. So it's really this trade-off, do I need this kind of explainability and really the situation where you're in.
In Bosch, do you make money? Are you profitable already using artificial intelligence, or is it still more in labs?
Yeah, I would say so. It's a good investment that we are looking into AI and enable Bosch to save a lot of money by that.
All right, Kai, thank you very much. Thank you for your keynote and have a good time. Thank you.
Thank you.